Hey my ninja warriors, welcome to yet another power packed session. I am Namrata, your mathematics expert, and we are doing 1000+ questions. Today the session is going to be about class 12th topics. So there will be calculus questions, there will be matrices questions, there will be vector and 3D geometry questions. So we'll be straight away starting with the very first question over here. But before I proceed, before I get into more details of the session, please let me know whether I'm perfectly audible and visible so that we can proceed with today's session. And let me just open the chat. All right. I can clearly see that, yes, game over Tamil, absolutely on time. Rakesh, good evening. Vijaya, Veni Shetty, and then we have Ragul. All right. Yes. Hello. Welcome to the session. Just one request that do like the session and share this session among your fellow JEE aspirant so that we can have maximum interaction, maximum fun in this session. Right? Yes. Are we ready? Yes. I guess we are ready for the questions now. So the very first question. Yes. So the very first question of today's session. Any guesses from which topic we are having the first question? Any guesses? Any guesses from which topic we are going to have the first question? And by the way, I'm gonna give you homework today, a serious homework today, right? So by the end of the session, please make sure that you take screenshots, or I'll be sharing the PDF as well, or you're noting down the homework, because you know what? We will discuss some of the questions in this session and the remaining questions I'll be giving you as the homework, right? Okay. All right. Yes. Calculus, matrix, yes. Matrices B we have, yes, matrices. Yes, so the very first question is from relations. Let us understand this question. So the question says, by the way, today's session is not about PYQs, right? So today's session is a non-PYQ session, because I know that we have solved so many PYQs and you have seen a lot of PYQs. So we don't want to repeat the questions. So this is a new set of questions which I have curated for you. So this is the relation defined on set A. So this is your set A and this is your relation. Can you see this is your relation? That means in relation, this x comma y ordered pair will be sitting. Sin inverse x plus cos inverse y is given as pi by 2. So basically, whichever ordered pair satisfies this relation will sit inside my relation. Did you get it? So that means we need to decode this, we need to solve this to understand that what kind of ordered pair will be sitting inside my relation. Okay. Alright. So sin inverse x plus cos inverse y is equals to pi by 2. So it would be sin inverse x plus pi by 2 minus cos inverse x. So the equal to plus will be gone. Pi by 2 minus cos inverse y. So pi by 2 minus cos inverse y. Pi by 2 minus cos inverse y is sin inverse y. You know, inverse trigonometric formula. And this is your sin inverse x. Now, sin inverse x and sin inverse y are equal. This implies that x and y both are equal. Alright, x and y both are equal. That means in my relation, what kind of ordered pairs will be sitting? So 1, 1, minus 1, minus 1, 0, 0, all the ordered pairs which belong to this set will sit inside my relation R. Right? So first of all, this ordered pair, so basically x comma x. Right? So relation will have x comma x, and here x belongs to minus 1 to 1. So this is my relation, right? So x comma x, that means definitely my relation will be reflexive. That is for sure. It will be symmetric as well. See, if a relation is containing, suppose 1, 1, 2, 2, 3, 3, is it symmetric? Yes. So symmetric also and transitive also. If a relation is having 1, 1, 2, 2, 3, 3 and no other ordered pairs, basically this is an identity relation. So basically this is an identity relation. No. Some people are saying option A. Some people are saying this is non-transitive. Why? Why it is non-transitive? So non-transitive, for a relation to be non-transitive, na, we should be having such case that 1, 2 and 2, 3 are present, but 1, 3 is missing. If this is the case, if something is missing, then it is non-transitive. But you know what? There is no such condition. 1, 2, 2, that means A, B, B, C. A condition like A, B, B, C does not arrive, right? If the condition is not arrives, that means we can't say that this is transitive. Okay, this is non-transitive. So this is transitive. So it is an equivalence relation, my dear students. This is an equivalence relation, right? So what I'm trying to say is, suppose we have a relation which is having 1, 1, and we are having 2, 2, we are having 3, 3. What do you think? What do you think? Is this reflexive? Yes, ma'am. Is this symmetric? Yes, ma'am. Is this transitive? Yes, this is transitive. Why? Why this is transitive? Because for a relation to be non-transitive, this condition should appear. That 1, 2, 2, 3 is there, but 1, 3 is not there. So these two should be there and this should be missing. Then only we can declare this as non-transitive. I hope that you are getting my point. Okay? Alright? No, there is no actually chance that you are calling. Why are you calling it non-transitive? Give me reason. Give me a reason. And the reason is this only. This should be your reason. This should be your case of reason. Okay? How is it transitive? Yes, Nitish. Okay, one more time I can explain you people. So basically, you know what is the condition of transitive. So condition of transitive, yes, I'll be explaining you one more time. So condition of transitive says that if A, B and B, C both are present in my relation, right, then A, C should be there in my relation. Okay? If at all these two are present, then this should be present. If these two are not present, then we have to call it transitive. Right? So basically, to call it non-transitive, this is present and this is not present. If this is not the case, then we will call it as a transitive. So this is transitive. This is also transitive. All identity relations are reflexive, symmetric and transitive. Okay? Symmetric. Now Fire Hunter is saying, ma'am, why it is symmetric? Symmetric means, okay. So symmetric means simply that if 1, 2 is present, then reverse, that is 2, 1 should be present. If 2, 1 is missing, that this is not symmetric. So can you see this x, x, the relation is having both ordered pair equal. This is the condition. Ordered pair element both are equal. So x, x, the symmetric pair will be x, x only. Right? Yes. So this is symmetric. I hope now this is clear. So this is symmetric, transitive and reflexive. So yes, this is it. The second question is from functions, a very good question. Yes, Gryfinder. Yes. Correct. Okay, so let us move on to the next question. Very good question. This is fx is this. For all x belongs to rational number, then the value of this is what we need to figure out. Okay. So first of all, in such question, basically in series question, what happens in series question, understand, realize, what happens in series question is, you have to understand the pattern between first and last term. You have to understand the pattern between first and last term. So can you see this is 1 upon 109 and this is 108 upon 109. What is the relation? Who is going to tell me? So if you add these two quantities, 1 upon 109 and 108 upon 109, can you see that if you add this and this, you are going to get 1. Right? So if I consider this quantity as x, so this is f of x, so this quantity will be f of 1 minus x. Right? Yes? Agree? Okay, I can see some answers over here. All right, yes. And now can you see, so this is fx, this is 1 minus x. All right, what about this 2 upon 109 and over here I'll be getting 107 upon 109. So 2 upon 109, 107 upon 109. If you add these two quantity, again you are going to get 1. So if this is x, this is 1 minus x. Okay, so what we will be doing is, we'll be combining first and last together. So 109 plus f of 108 upon 109. Plus we are having f of 2 upon 109 plus f of 107 upon 109, and so on. So we are having, actually we are having 108 terms. So how many pairs we'll be having? 54 pairs we are having. We will be having 54 pairs. Okay. And as I told you, each term, each pair will have f of x plus f of 1 minus x. So this is my main focus. F of x plus f of 1 minus x is what we need to figure out. In such question, please do not target any specific pair. Rather, you have to target the general thing. So general thing over here is f of x plus f of 1 minus x. Okay. Now what is f of x? So this is what we are trying to calculate. F of x is exactly this. So f of x is 3 raised to power x upon, can I open it? So this is 3 upon 27 upon, we are having 1 by 3 raised to power x. Right? Yes. Sorry. Can I write it the same way only? I need to write this 3 raised to power 1 minus. So this is same thing. Do not disturb it. So 3 raised to power 1 minus x plus 3 raised to power x. This is your fx. Correct? Now what about f of 1 minus x? To find f of 1 minus x, you have to replace x by 1 minus x. So in place of this x, I am going to write 1 minus x. So this is going to be 3 raised to power 1 minus x upon 27 whole upon. So now 1 minus x will get replaced by x and x will get replaced by 1 minus x. This is what we are getting. Okay. Oh, am I stuck? Oh. I guess I chose the wrong studio. Yeah, it's fine now. Yes. It's fine. I am in the same studio where previously this problem was happening. Okay, no issue. I am back. Okay. So yes, one more time I will explain you. So this is what we need to calculate, f of x plus f of 1 minus x. Okay. F of x is exactly same thing. We've copied and paste f of 1 minus x. For that, x will be replaced by 1 minus x. So this will be 1 minus x. Okay. This will, now 1 minus x will be replaced by x. So this will be x and this will be 1 minus x. But can you see in both the terms, if I talk about both the sum, denominator and denominator both are same. So what is the denominator? 3 raised to power 1 minus x plus 3. Common denominator we are having. And this. So this is 3. So and 1 by 27 I can take common. And over here we are having 3 raised to power x plus 3 raised to power 1 minus x. Oh my god, can you see that this value is nothing but 1 by 27. Okay. That means x plus f of 1 minus x is a constant value independent of x, that is 1 by 27. So this is again f of x. This is 1 minus, this is going to be 1 by 27. This is also going to be 1 by 27 and so on. All the pairs, the value of all the pairs. Oh, bhai sahab. What has happened? क्या glitch आ गया है ये? Oops, I guess I have to change the studio. Okay. Okay, I have to change the studio. While I am changing the studio, it will take me 2 minutes. It will take me 2 minutes to change the studio. Okay. And let me just call the team. Until the time, what you can do is you can like the session. Okay. Yes, I know there is a problem. Are you able to hear me? Yeah, I am changing the studio. Yes, yes, yes. Okay, give me just 3 minutes. 3 minutes, and yeah, 3 minutes. I'll be changing the studio. Okay, give me 3 minutes. Okay. 3 minutes. Yes. Hmm. Yeah, Ashwin, same issue I am facing in that studio, so we need to do that auto stop. Pradeep, okay, yeah, okay, okay. Yeah, Pradeep, actually my video got stuck, so I need to change the studio. There is some problem with the studio. So you have to do that auto stop. Okay. Another link. Okay. But we can't we do that auto stop while I can go to the another studio? Okay, I'll ask Mithun. Mithun have access क्या? ठीक है, okay, I'll try. या मिथुन, नम्रता हियर. वो मेरा सेशन अटक गया है, ये स्टूडियो में कुछ प्रॉब्लम है. तो 2 दिन पहले भी ऐसे हुआ था, तो वी नीड टू डू दैट ऑटो वाला. हाँ, नहीं आपको कर, क्योंकि अश्विन भी नहीं है और अवेलेबल प्रदीप भी नहीं है. आप हो लैपटॉप के सामने? हाँ 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 हाँ, ठीक है. हाँ, ठीक है. ओके ओके, या. All right, so I guess it will take me 2 minutes more, okay, so that I'll be because if I stop here from here, na, if I stop the stream from here from the studio, so this session will get over, okay. So if I want to continue, somebody has to like stop the streaming, take the streaming control, and I will be shifting the studio and then starting the streaming, okay. All right, yes, yes, yes. Okay, 2-3 minutes more. I was actually, let me just try one more time. Or, yeah, this stream got stuck. And Yes, I am back. We are live again. We are live again. Yeah, yes. Finally. All right. Perfect. All right. So let's start with the one question. We did only one question. Okay. So let's start with the second question now. Yes. So in this question, oh, okay. I guess I'll just shift the camera a bit. Yeah, I'll align a camera. I guess it's better now. Yes, so now you can see the question clearly, right? Yes. Okay. All right. Yes. I guess still there is a scope. So yes. I think better. Yes. I'm back. Let's start. I hope that we will not face any technical issue now. All right. Yes. I'm back. Okay, so in this question, fx is given to us and this was asked. So I have already told you this is your x, this is your 1 minus x. So we have calculated f of x plus f of 1 minus x and we were getting 1 upon 27. Okay. What does that mean? That first and last term. So first term is having f of 109 and last term is having f of 108 upon 109. That simply means that if you add, this is x, this is 1 minus x, so this is 1 by 27. Right? Now we are having f of 2 upon 109 plus f of 107 upon 109, right? So again 1 by 27. So I am gonna get 1 by 27 every time I get a pair. So how many pairs are there? Who is going to tell me? So total 108 terms are there. So if I club these two terms together, so every pair, how many times we can write the pair? So 54 pairs will be there. So 54 upon 27. So this will be your answer. 2 is the final answer of this question. Yes? Okay. All right. So 2 is the correct answer of this particular question. No. This is functions. Now function is from class 12th, relations, functions. And then we are having again functions we are having, right? So functions, class 12th. So this is this is your function. Fx plus f of 1 minus x is given to you. And you're looking for value of log of 1001 minus f of 1001. So basically, the moment I look at this question, I realize that I have to calculate f of x. Right? F of x is what we need to calculate. We need to solve for f of x. So this is my functional equation. And you know what? Since past few years, questions related to functional equations are quite popular. This is log of base 10 modulus x. Right? So this is fx. This is f of x minus 1 by x log of mod x by base 10. Clear? Now, how to tackle such questions? So, in such questions, what we need to do is we just need to replace x by something which is given in the question and we need to add or subtract the equation. So, there is some manipulation. The very first step will be, I'll be replacing x by x minus 1 upon x. Let's do that. So, here x will be replaced by what? X minus 1 upon x plus. Now, these two x will get replaced by x minus 1 upon x. So, x minus 1 upon x. So, this is going to be, if you do that, x is replaced by, yes. So, x is replaced by x upon x minus 1 upon x. Right? X minus 1 upon x. So, this is your what? Eraser. If I use the eraser and if I write, yes. 1 minus 1 by x. What do I get? Tell me. So now this x will be replaced by, so 1 upon 1 minus x. This x will be replaced by what? Tell me. X minus 1 upon x. If I solve it, what do I get? So x minus 1 and x minus 1 minus x. So this is going to be, so x minus 1 minus x. This is going to be 1 upon 1 minus x. Oh, Okay, so now here what I'm going to write is 1 upon 1 minus x, and that will be equals to log of base 10, and inside the modulus I'll be writing x minus 1 upon x. This is your first equation, right? This is your first equation. I hope that this is clear. All right, this is our first equation. Now what about second equation? How to do that? How to just understand it? Now your x will be replaced by, C. X will be replaced again by the same quantity, so that you get something which is meaningful. Okay, my voice is low. Is it better now? Is it better? Right? So now again, your x will now get replaced by, what? Oh, क्या हो रहा है ये? Oh. X will now get replaced by x minus 1 upon x. So what do I get? What do I get if I replace x by this? So again we need to calculate this. 1 upon 1 minus x. So this is f of 1 minus x. 1 upon 1 minus x plus. Now if you replace this, so you are going to get plus fx. And you are going to get what? Log of base 10 to the and inside that you are going to get 1 upon 1 minus x. This is your third equation. Sorry, second equation. Yes. Let me just explain you this question one more time. Right? So this question is a slightly difficult question. So what we saw was, this was the equation given to us. Let me mark this equation as 3. The moment I saw this equation, I realized that I need to replace this x by this value. This is what? X minus 1 upon x. So let's replace x by x minus 1 upon x. So x will be replaced by x minus 1 upon x, right? And over here 1 minus 1 upon this x. If you put this value over here and solve it, you are going to get 1 upon 1 minus x is equals to log of mod of x. Now this x will be replaced by again x minus 1 by x. Now we are going to repeat the same process one more time. X will be replaced by x minus 1 by x. So now what will happen? So again, can you see this quantity? If you solve it now, if you replace x by x minus 1 upon x, what do you get? You get 1 upon 1 minus x. And here if you replace 1 upon 1 minus and you place this x minus 1 upon x in this value, what do you get is fx. And if you place again x minus 1 upon x in both the places of x, what do you get? Log of 1 upon 1 minus x. Basic calculation. Okay. All right. I hope that this is clear. Now what I need to do is, can you see these three equations 1, 2 and 3? Yeah, Sumathi is saying, but why are we taking particularly x minus 1 upon x? Yes, Sumathi and Hasini. So basically most of you are having this question that why do you think that what is the procedure? So there is a set algorithm to solve such functional equations. What is that algorithm? So over here, two values inside the x you are able to see. This is your x. What is this? X minus 1 upon x. So always we do this only. We replace our x by this so that we get this. And till now, if you carefully observe these two equations now, so we have actually, if we subtract these two, we are not going to get fx. So that's why we have to repeat this process one more time, because we were not getting what we required. Okay, so we did the same thing. Now we are having three equations, right? What I want is this fx, and this is also fx, right? So third equation and second equation can be added together so that at least I get 2 fx. I want to protect my fx, right? Okay, I don't want this. 1 minus 1 upon x. This is I don't want. So can you see that this thing and this thing both are same thing? If you take it independently, this is 1 minus 1 upon x. This is also same thing. That means third and 1 will get subtracted. So can you see 1 third plus 2? So I need to subtract the first equation, right? So what we will do is basically 3 plus 2. So we need to add these two equations. What do I get? I get 2fx. I get 1 upon 1 minus x and 1 minus 1 by x. And I need to subtract the first equations. Can you see? This will get cancelled out by this if I subtract 3 minus 1. And can you see 2 minus 1? So this and this will also get subtracted. This is 2, this is 1. So 2 minus 1. So 2 minus 1. Right? So 2fx, and on the right hand side again same thing. So 3 will be log x, log mod x base 10 plus. We are having 2. What is 2? So this is your 2. So log of 1 upon 1 minus x mod 10 minus, we are going to have this, which is log of mod of x minus 1 upon x. This is your log 2fx. That means now you got this. Now you got this. 2fx value you are getting now. You just have to solve it. So yes, 2fx. Tell me what is the value of 2fx. So these two will get added. So log a plus log b, log a into b. So this is log of x upon 1 minus x to the base 10, right? And this is minus. So you have to just divide upon x minus 1 upon x. So you have to divide. So this is x minus 1 upon x. This is whole mod. This is your 2fx, right? So xx will get x square. 1 minus x minus 1 will become x minus 1 whole square. So this is going to be x upon 1 minus x. Since mod is here, we don't have to worry about the negative or positive sign. So this is 2. This is 2fx. Now this 2 will come in front over here. It will become 2 log x upon 1 minus x. 2x gone. And you are left with your final fx, which is nothing but log of base 10 mod of x upon 1 minus x. All right. Yes. Okay. So now you are having fx. And what you need to calculate is log 10 1001. So this value, let's calculate. Log of 1001 to the base 10 minus, we are having f of 1001. F of 1001, what would that be? So this is 1001 and 1 minus 1001 will be 1000. And mod is here, we don't have to worry about it. Now can you see that if you solve it, this is log of 1001 to the base 10, right? Then you have minus log of 1001 to the base 10 minus log of 10 cube to the base 10. So these two are getting cancelled out. Minus minus plus 1, 3 log 10 to the base 10. So that is 3 will be the right answer. 3 will be the right answer. Yes, 3 is absolutely correct. So I know this is the third question is actually a beta question, I would say. That it is not difficult to decode. It is not difficult to decode this question, but I agree this was a lengthy question. Okay. All right. Yes. So this is from the chapter functions. Okay. All right. Yes. So now let us move on to the next question, which belongs from ITF, inverse trigonometric function. And this is my favorite. Tan inverse series, whenever I see, I'm like, I'm gonna nail it. I am gonna kill it because I love tan inverse summation series. Okay. And I know there is a set algorithm, right? There is no hidden thing in it. The moment I see tan inverse, I know that end goal is one thing, that I have to do this, convert this series in tan inverse A minus tan inverse B. I have to convert this series in this form. Right? Let's do that. So first of all, let us calculate the general term. Shall I do that? So this is, can you see x square plus x plus 1, x square plus 3x plus 3, 5. Okay, so can you see this 1, 3, 5, 7. So if I calculate the TR, general term, let us calculate. So it is going to be tan inverse 1 upon, right, tan inverse 1 upon, and we are having x square plus 1x, right? So x square plus 1357. Who is going to tell me? 1357 and so on up to n terms. So about rth term. So this is actually nothing but 2n minus 1, right? In 2n minus 1 or 2r minus 1. The moment you put 1, what do you get? 1. The moment you put 2, you get 3. The moment you put 3, you get 5 and so on. So this is it, and we are having the last term. Now what is this? 1, 3, 7, 13. Oh, 1, 3, 7, 13, right? 1, 3, so 7. What is the general term of 1, 3, 7, 13? Who is going to tell me? Who is going to tell me 1, 3, 7, 13? Seven, 13. 1, 3. General term of 1, 3, 7, 13. 2n plus 1 you are saying? No? Okay. So just observe it this way. X square plus x plus 1. X square plus 3x plus 3. X square plus 5x plus 3. So this is actually nothing but, so this is 3. So 3 plus something, 1 plus 7 can be written down as, okay. How to solve it? So 2. So that is going to be r minus 1. Okay. All right. Okay. So now to tackle this question, what we need to do is, this is 1. Okay. Erase everything. I'm erasing everything. Okay, let us, so this is actually, we are not able to create the general term, you also saw. So what we can do is, we can just write tan inverse first term. Let us observe first term, 1 upon 1 plus. So this is x square plus 1 into x. So x plus 1. This is your first term, sorry. This is your T1, right? What about T2? So tan inverse. T2 would be 1 upon 1 plus x square plus 3x plus 2. So let us write it as 2 and 1 plus. So x square plus 3x plus 2. Can you see x plus 1, x plus 2? All right, now we are getting it. Now we are getting it, right? One by one. What about this? So this 7 can be written down as 1 plus 6. X square plus 5x plus 6. So can you see T3 is what? Tan inverse 1 upon 1 plus x plus 2, x plus 3. This is your T3, right? Yes? Okay. So this is actually much simpler version. Now by looking at this, I can write Tn as well. Can I write Tn? Who is going to tell me the Tn? Tan inverse 1 upon 1 plus. Now to write Tn, we need to understand the pattern. In the first term, we are having x plus 0, x plus 1. Second term, we are having x plus 1, x plus 2. Third term, we are having x plus 2, x plus 3. Nth term will be having x plus n minus 1. So can you see? Third term, we have 2, 1 less than it. So that's why x plus n minus 1 and x plus n, this is your last term. Okay. And now what you need to figure out? What you need to figure out is, so you have to write this expression as tan inverse A minus tan inverse B. Okay. So this is 1 plus A, B. So what I'll be doing is 1 plus x plus 1 is A, x is B. So 1 plus AB, and this is x plus 1 minus x inside tan inverse, and this is it. So can you see the formula now? Can you see this 1 is replaced by x plus 1 minus x? So the back to 1, and this is 1 plus AB. So tan inverse A minus B whole upon 1 plus AB. So can I write over here? Can I write tan inverse A minus tan inverse B? So the first term will be tan inverse x plus 1 minus tan inverse x. What about T2? What about T2? Similarly, over here, this 1 can be replaced by x plus 2 minus x plus 1. Right? So, tan inverse A minus B whole upon 1 plus AB. So, again, tan inverse x plus 2 minus tan inverse x plus 1. Now we are getting it, right? Now we are getting it. Okay, so you are not able to see the right hand side of the screen. All right. Oh, what's wrong with it? Oh, I've zoomed it a lot. Yes, clear. Okay, so this is, okay, am I visible properly now? Or have I shifted the zoom? Okay, so this is the best I can do. This is the best I can do. I think it's fine. Is it blur? Is it blur? Chalo, let's try to finish this off. Finish this question. Now tell me T3. Now you know the hang of it. Now you've got the hang of it, right? So this is tan inverse x plus 2. And finally, Tn will be equals to tan inverse x plus n plus tan inverse, sorry, minus tan inverse x plus n minus 1. If you add everything, what do you get? So can you see these two are getting cancelled out? So if you add all the terms, sum will be what? Tell me. So this will be left out and this will be left out. So that would be tan inverse x plus n minus tan inverse x. Okay. So now if you combine, again apply that formula, tan inverse A minus tan inverse B. So that is tan inverse A minus B whole upon 1 plus x, x plus n. x cancel, so tan inverse n upon, okay. So now this is your tan inverse. This is your y, actually y is nothing but n upon 1 plus x square plus nx. This is your tan inverse, okay. This is your tan inverse. Yes. Okay, let me just zoom, make it visible, try a little bit. Yes, okay. So yes, if you, so you are having y is equals to this, okay, all right. Or right away what you can do is, you can just skip this step and this is your y. Final y is this only, right? Because you have to differentiate it. So this is your final y. You don't have to perform further steps, right? So very easy question actually. So the moment you saw the tan inverse 1 upon this, so 1 plus x plus 1, right? So this is figured out as this. And if you add, this is what you get. Now what you need to figure out is y dash 0. That means you're looking for dy by dx. So this is 1 upon 1 plus x plus n whole square minus 1 upon 1 plus x square. Differentiation normal. And you put x equals to 0. What do you get? So 1 upon, so y dash of 0 will be nothing but 1 upon 1 plus n square minus 1 upon 1. So if you combine, if you take LCM, what do you get? So 1 minus, yes. So finally you are going to get, okay, option 2 matching, absolutely matching the moment you take LCM. So I guess Rinzuala has already given the answer, and just let me know if you have understood this question, because in this question we have faced a lot of technical issue, right? So I hope that you understand it, okay? All right. Yes. So this was your question. Let me just summarize this whole question. 1 upon 1 plus, so these two will be x plus 1. Now again, 3 will be written as, so 1 will be separated, so x square plus 3x plus 2, right? X square plus 3x plus 2 will be x plus 1, x plus 2, right? So all these terms, I have already showed you this, right? So this is the first term. Second term, so x square plus 3x plus 2, 1 will be taken care over here, and so on, right? And eventually T1 will be this, T2 will be this, T3 will be this, Tn will be that. If you add, you will get y. What you are figuring out is y dash. You differentiate it, you get the answer, and that's all. Okay? All right. Now let us move on to the next problem. Again, from the functional equation this problem is, and the problem says that your function is given f of 0 is 1, and this functional equation is given. We are looking for f of 3, a classic problem, a typical problem wherein how to solve such problems. So basically, to solve such problem, we have a set algorithm, a set method, a set steps, right? So can you see this is 2x and this is x? So every time what you need to do is, you need to successively replace x by 2. Replace x by 2. If you do that, what do you get? So 2x, so x will be x by 2. So this is f of x. So basically in each and every step, you have to take half of your x. So this x will be replaced by x by 2, and this is x will be replaced by x by 2. One more time you have to do it. Successively you have to do it. Okay, multiple times you have to do it. So this is f of x by 2 minus f of x by 2 square is equals to x by 2 raised to power 2. Successively you have to do that n times. Okay. So last May, what do you get? So this is your first time you have replaced, second time you have replaced. Now nth time if you replace, you are going to get f of x upon 2 raised to power. So nth term will be what? If this is first term, this is second term, this is third term. So you can just simply write f of x raised to power 2 raised to power n minus 1 minus f of x to 2 raised to power n, and over here x raised to power 2 raised to power n. Like this, okay? Whichever is here, this and this term same, that's why this and this term same, okay? Successively, you have to replace x by 2. So this is how you get, and you have to add. And you have to add, okay? So the moment you add now, so this is minus, the moment you add everything, can you see this and this will get cancelled out? This and this will get cancelled out. This will get cancelled out with the next term. So that's how the similar thing is happening over here. So this will get cancelled out with this. So last term and the first term will be left out, okay? So this is going to be f of 2x minus f of 2 by x by 2 raised to power n is equals to, on the right hand side, what are you going to get is x plus x by 2 plus x by 2 square and all the way up to. So if you take x common, this is 1 plus 1 by 2 and all the way up to 1 by 2 raised to power n, right? Yes, Jeevan sir, I'll give this your answer. Now this is a procedure. Now you have to put n equal to infinity. Yes, the moment you put n equal to infinity, this will remain same. Yes, ma'am. What about this? So n is infinity, ma'am. So 2 raised to power infinity will be 0. So this is f of 0. And on the right hand side, if you put, ma'am, if you're putting n equals to infinity, that means infinite geometric progression. How to behave with infinite geometric progression? Very easy. 1 upon 1 minus r. So this is 2x. F of 0 is given to us in the question. F of 0 is 1 and this is your 2x. So basically f of 2x is nothing but 2x plus 1, or we can say that f of x will be x plus 1. This is your function. This is your function. F of x is equals to x plus 1. And now we are looking for f of 3. So f of 3 is clearly 4 is the correct answer. Yes, 4 is the correct answer. Right? Yes. So let me just explain you one more time with the help of, let me explain you one more time. So this was your original equation, right? This was the original equation given to you. Now can you see, this is your 2x and this is your x. Okay. Can you see that if you take half of it, you will get this, right? Yes. If you replace x by 2, what will happen? So this 2x will become x. First of all, this is an advantage, okay? So the point of taking it is that you get fx. You get fx, okay? And this is x by 2. Can you see the similar terms will get created? The logic behind this, first of all, let me tell you the logic. That this is 2x, this is x. So can you see the half of 2x is x. So here only in the first equation only can you see, if you want, what is the relation between f of 2x and f of x? Tell me. So if you replace x by 2 in this, you are going to get this or not? This is the relation, right? First of all, this is the logic. And second of all, that what is the trick behind it? So this is the trick. This is how we do it. If 3x was here, not 3x and this is x. So we would have replaced by x by 3. Are you getting my point? Right? If in place of 2x, 3 was written, so 3x minus f of x. So we would have what we would have done? X by 3. Right? If 4x and x, so the ratio you need to take. You need to take the ratio x upon 2x. What is x upon 2x? So this the ratio you need to take. Okay. So now successively just replace, keep on replacing till you get this. And you will understand the logic. Now just add everything. The moment you add, the similar terms will get cancelled out. That's what we wanted. So first this term and this term will be left out. So we are having this and this. and over here x, if you take common 1 by 2, 1 by 4 until this. Now n tends to infinity. If you put n tend to infinity, this is x by infinity 0. F of 0 is given in the question. F of 0 is 1. So just this is 1. And if n is infinity, this is infinite geometric progression. X will be out and 1 to infinity. So this is 1 minus half. And yes, finally you are going to get what? Finally f of 2x will be what? 2x plus 1. So now how do you do that? Replace x by 2 to get f of x. So this is x. Now f of 3, f of 4. No, they will not give, Hasini. They will not give. The point is, it should be fraction. Okay, so the ratio should be fraction. Because the moment you put infinity over here, no, the 2 raised to power n or 3 raised to power n should be in the denominator. That's how we design the question. Now we have another question from limits. Okay. Now we have another question from limits. Okay. So x tend to infinity. Right. So 3 by x, 5 by x. Okay. So over here inside the sign I am getting a 0, here also 0. So 0 by 0 form clearly we can see. So why not we do one thing? We put x equals to 1 by t. If x is tending towards infinity, t will be tending towards 0 plus. Make sure it is 0 plus. Okay. Alright. So this is cos 2t minus cos 3t cos 5t upon we have sin 3t and sin 5t. Correct? Limit t tend to 0 plus. Right? Yes. Now this question is much simpler, in much simpler form. Now sin 0. So I need a 3t over here and I have to divide by 3t so that this is 1. Sin 3t by 3t is 1. Similarly, I need 5t and 5t so that 5t 1. So what I am left with, okay. So we are left with what? Can you see 15t square is in the denominator. What about numerator? Cos 2t. Now we need to apply the expansion. Yes, applying expansion is the best thing in this particular problem. Or what you can do is you can also do that cos c 2 cos a cos b. So 2 cos a cos b also you can do, but again I'll be applying expansion. Do you know the cos x expansion? 1 minus x square by factorial 2. And rest terms I'll be ignoring, just that. So what about this? 1 upon 2t, so 4t square by 2. Rest terms I'll be ignoring right now. Okay. Minus. We are going to have 1 minus 3 3s are 9t square by 2. And 1 minus 25t square by 2. Okay. Alright. This 1 and 1 are getting cancelled out. Okay. 1 will get cancelled out. So we are left with over here minus 2t square. I am collecting coefficient of t square. So this is minus 2t square. What about this? If I multiply this, what do I get? First of all, 1 multiply 1, I'll get 1 which will get cancelled out. Then minus 9t square into 1. Minus sign is here. So plus 9t square by 2 will be there. Minus 25 into 1. So and minus is there, plus 25t square by 2. And over here 15t square. T square, t square, t square. So this is plus. T square will be gone. So 9 plus 25 is 34. 34 minus 2 is 32. And 32 by 15. Let me just check. So yes. Okay. So 2 square 4 by 2. 1 is the correct answer. Okay. 4 by 2 is 2 minus 2 plus 9 and okay. 25 plus 9 is so 17. 17 minus 2 is 15. Okay, 15 by 15, that is 1 is the correct answer. Option 4. Yes. Done, done, done. Can you see? So this is t square gone. 25 plus 9, 34 by 2, 17. 17 minus 2 is 15. 15 by 15, 1. Option D. Final thing. Okay. Alright, I hope that this question is done. Shall I move on to the next problem? Yes. So this is my next problem from the world of differentiation. Yes. So okay. So we are looking for point of non-differentiability. So we just need to plot this. That's it. But in what interval? 0 to infinity. Can you see the domain 0 to infinity? So first of all, I'll be plotting x square. Second of all, I'll be plotting mod x. And this is your 1. And you are looking for maximum of it. Let me just overline only the maximum part. So tell me, x square and mod x, which one is greater? So this time mod x is greater. But once this crosses 1, 1, is the point. Can you see that x square takes the lead? So over here, if I talk about, this is the only point of concern. X equals to 1 is the only point of concern. And we are not sure. Okay. So for that, what we need to do is f of x. Let me just write it down. So definition changes basically. F of x will be equals to, so x square when x is greater than or equal to 1. And x when x is less than 1. I am not talking about the negative thing. So 0 to 1 we are talking about. So this is 0 to 1, right? Now differentiate f dash x. So this is 2x when x greater than 1. And this is 1 when x less than 1 and 0 to 1. So can you see, the moment you put x equals to 1, your right hand derivative is 2, left hand derivative is 1. So that's why, it's not differentiable at x equals to 1. Number of points is absolutely option 2. So at x equals to 1, it is not differentiable. How many number of points? At B point. Okay. Clear? Let us now move on to the next problem. Okay, one more functional equation. You will be like, ma'am, you're killing it. Today only questions from functional equation. Why? What happened? So this is the last question from functional equation, because from last few years now, they are giving questions from functional equation, right? So how do you solve it? Shall I give you this question as homework? Yes, one more functional equation question. Shall I give you this question as homework? Okay, so this is your homework question. Okay. I'll be sharing the solution as well. Okay. All right. Chalo. So if this is a homework question, let us try this question now. This question is from application of derivative, where it is said that fx is a monotonic increasing function. That means clearly f dash x is greater than 0. Right? F dash x is greater. Yes, integration. I have a lot of questions from integration today. So how to differentiate it? So first of all, 2 sine plus 3 cos whole square. Applying quotient rule. 2 sine plus 3 cos constant. And derivative of this will be what? So lambda cos minus 6 sine. We have a negative sign over here. This time lambda sine plus 6 cos is constant. And 2 sine. Can you see 2 sine? So 2 cos minus 3 sine. So this is it. This should be greater than 0. First of all, this is greater than 0. Right? Okay. So let us focus on the numerator part. Can you see that? Okay, first of all, let's talk about how much. So we are going to get sine square, we are going to get cos square, and we are going to get sine cos. Right? That's it. Sine square, cos square, sine cos. First of all, let's look for sine square. How do you get sine square? So 2 sine square, 2 sine into 6 sine. So this is minus 12 sine square. Okay, from here as well. So overall sine square, coefficient of sine square. So minus 12, and we are going to have minus plus 3 lambda. So minus 12 plus 3 lambda times we are having sine square. What about cos square? How do you get it? So 3 lambda. So plus, we are having 3 lambda cos square. And yeah, that's it. 3 lambda cos square, and from here cos square will be minus 12 cos square. Yes, so 3 lambda minus 12 cos square x. Okay, what about cosine? Now we are going to have cosine as well. So can you see 2 lambda sine cos and minus 18. So plus 2 lambda minus 18, right? So 2 lambda minus 18, and from here we are having sine cos. So minus 2 lambda, and we are going to have 6 is a minus 18 minus 2 lambda plus 18. Okay, into sine cos. So this is what we have figured out the coefficient. Now can you see the 2 lambda gone, 18 gone? That means sine cos term is not visible over here, right? And also if you take 3 lambda minus 12 common, what you're going to get is, so 3 lambda minus 12, if you get common, you're going to get sine square plus cos square, which is nothing but 1 whole upon you have 2 sine plus 3 cos whole square, and this should be greater than 0. Now you're getting the value of lambda. So lambda is nothing but greater than 12 by 3. 3 4s are 12. So yes, lambda is greater than 4. Lambda is greater than 4. Okay, so lambda is greater than 4. That means that, so lambda greater than 4, right? Yes. So which answer should be correct? Tell me. Then minimum value of lambda is equal to, negative are not possible. Lambda greater, right? Yes. So lambda greater than 4, minimum value. So minimum lambda greater than 4. Greater than 4 means what? 4.1. What is the GIF of 4.1? So option D is right now. Yes, minimum value you are looking for. Why you are saying 6? No. Lambda greater than 4 means what? Can lambda be 4.5? Yes or no? Can lambda be 4.1? Yes or no? Yes. So GIF of 4.1, 4.2, 4.3 and so on will be what? 4. Clear? Shall I move on to the next problem? Yes. Okay. All right. This is from methods of differentiation. Methods of differentiation, very good question from method of differentiation, wherein they say that gx is equals to inverse of fx. So how to tackle such problems? So first of all, let us figure out let us get rid of the inverse and write it in this way, that fog of x or f of g of x is equals to x. That Nitish, that's the expansion. That's the expansion of cos x. Just go and read all these. Just type on the Google expansion of cos x. You will realize that why did I do that. Expansion of sin x cos x, right? So this is it, right? The moment, so basically in some questions wherein inverse is involved and the derivative of inverse function, can you see g dash x means what? Derivative of f inverse x is asked. Never go by inverse method. Always go by f of g of x equals to x. That is one thing. Now differentiate. F dash g of x. Chain rule. G dash x is equals to 1. That means if you talk about g dash x, that would be 1 upon f dash g of x. Right? But you are looking for g double dash x. So why not just differentiate it twice? The same thing. How do you do that? So 1 upon something, the derivative will be minus 1 upon f dash g of x whole square. Right? Okay. Now what you need to do is differentiate. So f double dash g of x and g dash x. And now you just have to plug in the value g double dash 5. So g double dash 5, who is going to tell me? So that would be minus of f double dash g of 5. Then g dash 5 whole upon f dash g of 5 square. Right? So in here, I will require, first of all, what is g of 5? G of 5 is something which I need. G dash 5 is something which I will need. G of 5 and G dash 5. Okay. All right. How to calculate g of 5? So g of 5 is nothing but, so g of 5. G of 5 is, okay, can you see? G of 5 is nothing but f inverse 5. Right? G of 5 is what? F inverse 5. F inverse 5, that means that simply means that how do you get 5? What value of x you should put so that you get 5? Can you see that f of 1 is 5? F of 1 clearly is 5. But if f and g are inverse, can I say that g of 5 is 1? That's how it is. That's how inverse functions work. Right? That's x and y get interchange in inverse functions. So I can clearly see f and g are inverse. Clearly f of 1 is 5. Can I say g of 5 is 1? The reversal thing. Okay. So that means g of 5 clearly is 1. So what I can do is I can just replace this as 1 and this as also 1. So we are looking for f dash 1 square and f double dash 1. That is one thing. What is f dash x? Can you tell me? F dash x will be 3x square plus 1. F double dash x would be 3 to the 6x. The moment you put x equals to 1, what do you get? 4. The moment put x equals to 1, what do you get? 6. So f dash 1 is 4. So this is 4 ka square. And minus sign f double dash of x1 is minus 6. Multiply. Now g dash 5. How do you get g dash 5? Tell me. So g dash 5 will get from here 1 upon f dash. G of 5. What is g of 5 once? F dash 1. Now what is f dash 1? We've just calculated. F dash 1 is 4. Right? So this is 1 by 4. So that means g dash 5 now is what? 1 by 4. So this is 1 upon 4. So finally what we are going to get is, so yes, this is 3. This is 2. This is 16. 2s are 32. Minus 3 by 32. Option 3 is absolutely right. Yes? Okay. So minus 3 by 32, correct? Got it? Clear? How to solve such problems? Now we are having a question from integration. Let us get into integration. Yes. So dx upon 1 minus cos x sin x. If you know this format, the question will be cakewalk for you. Do you know what should we do? Who is going to tell me in the chat box? What should I do when I see cos x and sin x? A cos x plus b sin x plus c in the denominator, in the chat box. Please tell me quickly. Think about it. So the moment you see cos x and sin x in the denominator, what you have to do is you have to put tan x by 2 is equals to t. Tan x by 2 you have to put equals to t. Who knows this? Who remember this? Now you will be telling me, ma'am, what? Tan x by 2. And in the options also there is a hint, right? Okay. And ma'am, but where shall I get the tan x by 2 from? So I have a formula. Yes, tan x by 2. So cos x will be replaced by 1 minus tan square x by 2 whole upon 1 plus tan square x by 2. And sin x will be replaced by 1 minus tan square x by 2 whole upon 1 plus tan square x by 2. Right? Just quickly convert it. So now the moment you put tan x by 2 equals to t, sec square x by 2, 1 by 2, dx will be equals to dt. One by one, just convert this question. Let us do that. So dx upon 1 minus tan square x by 2, 1 plus tan square x by 2, and we are going to have minus 2t. Sorry, sin x का क्या लिख दिया मैंने? Sorry. So this is 2 tan x by 2. Sorry, same क्यों लिख दिया? Yes, so this is 2 tan x by 2, 1 plus tan square x by 2, and dx will be replaced by. So dx will be replaced by. So this is, yeah, this is it. So this is your dx. Okay, if you take LCM, what do you get? So you get 1 plus t square minus 1 plus t square minus 2t, and upar you are going to get 1 plus tan square. 1 plus tan square is sec square x by 2 dx. So this is going to be 2 dt. So this will get replaced by 2 dt, right? And integrate. So now this is it. So you are going to get 2 dt, and you are having t and t minus 2. Integrate. Right? Yes? Clear? Sorry, 2. One more 2. So t minus 1, and this is 2 cancel. Right? Now integrated. So this is going to be 1 upon t minus 1 upon t. Yes. Integration. So this is log of t minus 1 upon t. So this is log of mod of tan x by 2 minus 1 upon tan x by 2. So if you solve it, what do you get? 1 minus cot x by 2. Option 3 is absolutely right. Okay, option 3 is absolutely right. Have a look. Understand this. All right. So the moment you see cos x and sin x na in the numerator, what do? Tan x by 2 is equals to t. Differentiate. Half sec square x by 2 dx is equals to dt. Okay, this is cos x, this is sin x. So what did I do? I just replace this cos x by this, sin x by this. Right? And numerator is dx. Now take LCM. The moment you take LCM, 1 plus t square will be here. What is 1 plus t square? Who is going to tell me? 1 plus tan square is sec square. So this is sec square. Sec square dx, can you see, is 2 dt. So 2 dt. And this is 2t square minus 2t. 2 can get cancelled out, and t minus 1. So it is very easy to integrate, and we are done. Right? Okay, have a look. All right, again, another question from integration. Are we ready? Are we integration ready? So this is your question wherein x minus 1, x square plus 1 and x raised to power 4 is given to us. We need to integrate it. First of all, the moment I see this question, I realize that I have to break, or I have to do something so that it gets factorized and terms can get cancelled out. Right? So I feel x raised to power 4 and x square plus 1. Okay. So it is very obvious of me that I subtract 1 and add 1, so that I will get, okay, x, and separate out. Separate everything out. This is one term, this is another term. Right? So I had subtracted 1, added 1, denominator separated. Now let us focus on this. So this is a basic example of partial fraction. We can do partial fraction from here. So this is sorted. This I'll be able to integrate. Let us sort this out. Okay, so this is I1 plus I2. Let us do this. So this is dx. This is dx. I1 and I2. Let us talk about I1 first. Okay. I1 will be equals to, now open it, x square plus 1, x square minus 1. So x square minus 1 will be x plus 1, x minus 1 whole upon x minus 1 and x square plus 1. So this cancel, this cancel. So I1 is nothing but this. So I1 is coming out as x cube by 3 plus x. plus constant, right? Okay. Sorry, x square plus 1 is also getting cancelled out. So x, okay. So only x plus 1 is remaining. Oops. Yes. So this is remaining. X square plus 1 gone, x plus 1 is remaining. So x square by 2. X square by 2. Right? This is your I1. I1 is sorted. What about I2? So I2 can be easily done by partial fraction. How to do that partial fraction? So for I2, you have to write this 1 upon x minus 1 and x square plus 1. This should be equal to a upon x minus 1 plus bx plus c upon x minus 1 x square plus 1. Right? Now you just have to figure out the value of a, b and c. How do you do that? So just take LCM and do it. Okay. So 1 upon x minus 1 x square plus 1 is equals to, take LCM, x minus 1. This is gone. And x square plus 1. Yeah. So a times x square plus 1 plus bx plus c times x minus 1. These two are getting cancelled out. Now put x equals to 1. The moment you put x equals to 1, you are going to get this as 0. This will be 0. So a is equals to half. And the moment you put x equals to 0, what do you get is a plus, you are having, if x is 0, minus c. A minus c is equals to 1. So a and c, a minus c is equals to 1. So that means half. So c is minus half. A you have, C you have, B you can calculate. Will you be able to integrate it? Will you be able to integrate it? I'll show you the solution over here. So yes, this is very easy. This is what you need to integrate. So 1 by 2 minus 1 by 2, B is minus 1 by 4. Okay. Now integrate. Now you can integrate. So this is half log x minus 1 minus, you are going to have log of x square plus 1, okay, and minus tan inverse x. So this is how your expression will be, okay. All right. Now I'll be coming back from a water break and you're going to try this question, okay. Try this question. I'll be back in less than 30 seconds, okay. All right. This right side nothing is there. This is only, I can see that काम की चीज है. ठीक है. Root tan x plus root cot. Okay, root tan x plus root cot x. So you have to integrate it, right? So in such questions, what do we do is, so we just put tan tan x we need to put equal to t. Yes. Root tan x we need to put equal to. If I put root tan x equal to t, it will be t plus 1 by t. Right? Or we can say that tan x will be equal to t square. Oops, I forgot to wear my right. Tan x is equals to t square. Right? Now differentiate it. What is the derivative of tan x? Sec square x dx is equals to 2t. Now sec square x can be written down as 1 plus tan square x dx will be equals to 2t. Tan square x, so dx can be written down as 2t upon 1 plus t raised to power 4. Okay, so this is it. And we have 2t upon 1 plus t raised to power 4 dt as well. Yes. Right? Correct? Clear? And now the limits will get changed. So this is going to be 0 by 0. By the moment you put pi by 4 root 1, so 0 to 1, this is your expression. Right? T upon t plus 1. So this is okay. So finally, if I solve it, I get t square plus 1. And we are going to get tt cancel out. Okay, t square plus 1. Tt cancel out, 1 plus t raised to power 4. We have 2 integration dt. Very easy to integrate. This is very common problem. How do you solve it? Let me just show you. So now how do you solve it? So let's take t square common. T square you need to take common from here. So let us take t square common. So the moment you take t square common from numerator and denominator, you are going to get 1 upon t square minus 1 whole upon, you are going to get t square plus 1 by t square integration. And now you have to make t plus 1 by t whole square. So this is t plus 1 by t whole square minus 2. You are having a 2 with a negative sign, 1 minus 1 by t square t dt, right? The moment you take t plus 1 by t is equals to a or is equals to u. T plus 1 by t is equals to u. You differentiate, you are going to get this as du. So this is 2 du upon u square minus 2. This is what you need to integrate finally. This is what you need to integrate. Let me just show you over here. So yes, this is what you have to integrate. Plus ban raha hai kya? This is t square plus, sorry, this is plus 1 na. So this is plus. So you have to calculate minus wala, sorry. Plus tha to minus wala you have to calculate. Yes, so minus wala aega. If it is plus, so you have to give minus sign. Okay, plus. So yes, now what you need to do is t minus. If you see plus sign in the numerator, you have to create minus ka square and then you have to plug in. So now this is your u, this will be your du. So 2 du, right? So this will be 2 du upon u square plus 2. So this is gonna be 2 tan inverse u by root 2 and 1 by root 2, and in here you have to apply the limits. Okay, all right, I'm not gonna solve it completely, but I'll show you the result, the final result. So this is what we've got. The moment I put tan x is equals to t square, this was the expression. Now take LCM, so you will get this. Take t square common, you're going to get this. Now the moment you see plus sign in the numerator, now what you need to do is make perfect square of minus sign and put this is equals to t. So t minus 1 by t is equals to u. 1 plus 1 by t square will be du. So now 1 plus 1 by t square dt, this is your du and this is your u square plus 2. So integration of du upon u square plus 2. So that will give you this. And now you just need to complete the question. Yes, Vemi Shetty, I have replaced this. No minus sign. It is a plus sign. I just did it by mistake. Plug in the value finally and you'll get your answer. Give me a big thumbs up if you feel that yes, ma'am, we can do this question. Yeah, this is doable, ma'am. Yeah, some of you are saying that Hasini is saying I did this by changing tan x to sin by cos. That is also that will also work. Now this is a question from definite integration. Yes, a question from definite integration which says g of x is equals to 0 to x cos raised to power 4t dt. Then we are here to figure out g of x plus pi. Right? Very easy question. Very easy question. G of x plus pi. If I have to calculate, I have to replace just x by pi. Put x equals to x by pi. That's it. So x equals to x by pi. 0 x plus pi cos raised to power 4 t dt. Correct? Right? And now we are going to break it. We are going to break it. So 0 to x plus we are going to have 0 to x and we are going to have, or we can say yes, 0 to pi. We can start with 0 to pi. Yes, 0 to pi and then pi to pi plus x. Can I do that? This is your again cos raised to power 4t dt. Cos raised to power 4t dt. Correct? What is this? What is this? Is this not g of pi? Tell me. Is this not g of pi? Right? The moment I put pi over here, so this is 0 to pi. So this is g of pi. What about this? So we have a property related to periodic functions. And the property says that if you are having this as t plus any constant k and the function is suppose fx dx, whose period is this t? So this t and t will get cancelled out. This will be equals to 0 to k fx dx. Given that function is periodic. So cos raised to power 4, the period is pi. So this pi and pi will get cancelled out. So this is 0 to x. 0 to x. That means this is g of x plus g of x. Can you see this is, so g of x plus pi is nothing but g of x plus g of pi, option 1. Very easy question. Yes, ma'am, Idhi, absolutely right. Ma'am, why minus? Minus? Where minus? Oh, you're talking about the previous question, I guess. So this is it. Yes. Now we have another question from area under curve. Let's do a question from area under curve. So area bounded by. This is a downward facing parabola. Again a downward facing parabola and a straight line. Okay. So can you clearly see that I have to spend a good time in plotting of this curve very precisely. I have to be very sure while I plot this curve. So first of all, I'll be plotting two downward facing parabolas, right? So let me just take minus sign common. So this is minus of x square minus 6x plus 5, right? So I can clearly see that x equals to 1 is going to satisfy. So this is x minus 5. So 1 and 1, 2, 3, 4, 5. 2, 3, 4, 5. These are the two things. So this is my downward facing parabola. This is how my downward facing parabola looks. Okay. All right. This is first thing. Now let's take out minus sign common from the second one. So minus of x square minus 4x plus 3. Clearly here also x equal to 1 is gonna get satisfied. 1, 3. So again that means this parabola, okay. So this parabola is having this. This is that parabola. Can you see the second parabola now? Okay. Both are intersecting at point 1. So this is your, sorry, 3 na, so 1, 2, 3. Sorry, so I have to intersect this at 3. And let me just change the color as well. So this is 1, 2, 3. This is how your parabola will look like. And now you are having a line 3x minus 15. So how does this line will look like? So basically y-intercept is negative and the slope is positive. So that means my line might look like 15 is very, very down. And on the x-axis, if I put y equals to 0, I'll get 5. Oh, so this line is gonna pass with 5. That means this point. This is my curve. This is my curve. Now, let's shade the required portion. Can you see this is my shaded portion? This whole thing is my shaded portion. Just that I have to know this point. So I have to solve 3x minus 15 with my second parabola. Let's do that. So 3x minus 15 you have to solve with minus x square plus 4x minus 3. Right? So you are going to get x square minus x. And you are going to have minus 12 is equals to 0. So x is x minus 4 and x plus 3 is equals to 0. So x equals to 4 comma minus 3. Yes, 4 comma minus 3. So this point is 4. So the moment you put x equals to 4, 4 3s are 12 and this is going to be minus 3. So this is your point, 4 comma minus 3. This is 1, this is your 3 and this is your 5, right? So now can you see that if I start with 1 and if I start with 1 and proceed, can you see the upper curve is this white one and the lower curve is green one. It is happening till this point, till x equals to 4. So we have to break it at x equals to 4 because at x equals from 1 to x equals to 4, upper curve is this parabola, lower curve is this parabola. But what is happening after 4? After 4, upper curve is this white parabola, but the lower curve is the straight line. Right? So let me just write down the required area now. Integration from 1 to 4. 1 to 4, we are having upper curve as this. So minus x square plus 6x minus 5. This is your upper curve. Minus you are having lower curve as this. So which is minus x square plus 4x minus 3 dx. This is your this area. Now what about 4 to 5? What is happening between 4 to 5? Upper curve is still this minus x square plus 6x minus 5. But what about the lower curve? This is your lower curve which is 3x minus 15 dx. Getting it? Now you just have to integrate it. Let me just show you 1 to 4. This minus this, upper minus lower, 4 to 5, this minus this. So you just have to integrate it and I'm not doing the calculation because you have to do it. And the most important part of this was the curve sketching which I already done for you. Okay. Shall I move ahead? 73 by 6 your square unit. That means this option 3 is absolutely right. I hope that this is clear. Now one more question from again area under curve. So the question says maximum of sin x cos x half. Then the area of region bounded by the curves and x-axis and y-axis. So first of all, we need to figure out that what is happening. Okay, x equals to 2 pi. So this is sin x cos x. So sin x I have plotted already. What about cos x? Cos x will look like this. And yes, half will be 0.5. So this is 1 by root 2 which is 0.75. So half will lie over here. This is your half. And you're looking for the maximum. So maximum I will be shading right away. So maximum is cos x. So 0 to pi by 4. We are having cos x as the maximum value, pi by 4. Pi by 4 onwards, sin x becomes greater till this value, and this value is what? So this is pi minus of, so this is pi minus pi by 6, 5 pi by 6, right? 30 degree, because after that half will be bigger. So plus you are having pi by 4 to 5 pi by 6, we are having sin x, the bigger value. Can you see? And after 5 pi by 6, half is maintaining. So after 5 pi by 6 to some value, half will be there. So what is this value? When your cos x is half. Okay, so this is pi. And this is again 3 pi by 2, right? So 3 pi by 2 plus something. Plus we have 60 degree, right? 3 pi by 2 plus pi by 3. So we are having 3 pi by 2 plus 5 pi by 3, yes. So 5 pi by 3 say 5 pi by 6. This value is 5 pi by 6 say 5 pi by 3, right? 5 pi by 6 to 5 pi by 3, yes. 5 pi by 6 kahan gaya? Haan. So this is your 5 pi by 3. So 5 pi by 6 to 5 pi by 3, we are having half dx plus now after 5 pi by 3 till you can see 2 pi, that this area is, this cos x will be there. That's it. Did you get it? Did you get it? Did you get this? That what is happening? Which one is the greatest? So green color area is actually the greatest. This is what you need to understand. Okay. So if you solve it, you will get it, right? So this will be the correct answer, 5 pi by 12. Now integration is absolutely easy. Cos x integration is sin x, 0 to pi by 4. Plus sin x integration is minus cos x, pi by 4 to 5 pi by 6. Then integration of half is half x, 5 pi by 6, 5 pi by 3. Then we have integration of cos x is sin x, 5 pi by 6 to 2 pi. That's it. Now plug in the value. You will get D as the final answer. Clear? Correct? Perfect? Okay. Shall I move on to the next problem? Okay. So we are having a problem from differential equation. Yes, we are having a question from differential equation, right? Yes. So we need to understand this differential equation nicely. First of all, let's take LCM, left hand side pe. So 2 is there already. Can you see x dx minus y dy is there? Oh, x dx minus y dy. And we are having x square minus y square. So can I just shift this in the numerator? So this is x square minus y square equal to, we are having, okay, can you see this is crisscross? This is crisscross. Crisscross means what? So y dx minus x dy, let's take LCM. So dx is already here, dx will get cancelled out. On the right hand side, y dx minus x dy. Okay, y dx and upon we are having x square plus y square. Till now I hope that this is clear. No, it is not a homogeneous. Yeah, you can say that it's homogeneous, but it's actually the exact differential equation. This is the exact differential equation. Understand, realize. Okay. All right. Now, what to do, how to solve? First of all, we need to understand that the numerator is actually derivative of this denominator. What will happen if you differentiate x square minus y square? Tell me. If you differentiate x square minus y square, let me show you. Differentiation of x square minus y square is nothing but 2x dx minus 2y dy. Can you see that? And this is exactly what is written over here in the numerator. This is nothing but derivative of x square minus y square. And this is x square minus y square. So that means left hand side is sorted actually. So if you integrate it, this is actually dx by x. Integration of 1 by x. So this is log of mod of x square minus y square. And it is pretty clear from the one of the options as well that we are on the right track. What about LHS numerator is wrong? Why? Why? Numerator you are saying na, x dx minus y dy, correct to hai? Sorry, y dy, yes. This is by mistake, yeah. I have written same, correct over here, y dy, okay? And this is it. This is your LHS. What about RHS? What about RHS? In RHS, what you need to do is you need to take out x square common. Yes, homogeneous. X square, let's take common. The moment you take x square common, what do you get? So basically you have to divide. So y dx minus x dy, or what we can do is we can divide by x square upon x square, okay? And we are having 1 plus y upon x whole square. So can you see what is this? Can you see what is this? This is nothing but the derivative of y by x. Quotient rule, but with a negative sign. So on the right hand side, we are having the basically minus of dy by x. And this is 1 upon y by x whole square. Integration. Can you see? Tan inverse. So this is minus tan inverse y by x. Just pure observation. This is the exact differential equation, and plus constant is also there, right? So just shift this towards the left hand side. So I guess more or less I can see option 3 is matching, even if I'm not matching the constant now, because log is there, tan inverse y by x is there. You can just check the constant as well. So this is y of 1 is 0. So you put x equals to 1. You put x equals to 1. What do you get? Put x equals to 1, y equals to 0. So this is 0. X equals to 1, y equals to 0. Again 0. So C is coming out as 0. Yes, C is 0 the moment you put x equals to 1, y equals to 0. So this is how what you get. Option 3 is absolutely right. Correct? Yes. Okay. All right. So yes, this is it. Can you see that? This is it. This is your answer. Okay, now we have a question. Now you guys are going to tell me that this question is what? Whether this is linear differential equation or homogeneous or variable separable. Please identify this differential equation for me. Please identify this differential equation for me. Can you please do that for me? So if you try to observe, this is neither variable separable nor homogeneous, nor any reducible forms of variable separable or homogeneous. And if you check, this is not even linear differential equation, because linear differential equation is dy by dx plus py is equals to q, where p and q both should be function of x. But this q clearly is not function of x, it is function of y as well. So this is not a linear differential equation, but this is reducible to linear differential equation. Yes, reducible to linear differential equation. That means right now it is not, but you can just substitute it and then eventually you can form it. So basically this q should be function of x, right? For that you have to fix q. This y cube should not be here. So divide the whole equation by y cube. First of all, divide the whole equation by y cube. That is the first thing you should do. Okay. If you put 1 by y square is equals to t, what do you get? So y raised to power minus 2, so minus 2 will come in front, y raised to power minus 3 dy is equals to dt. That means that dy by y cube is nothing but dt by minus 2. Yes. So dy by y cube now will be replaced by minus dt upon dx, and this is 1 by 2 plus you have x. Y square is t is equals to x square. Now this is linear differential equation. Now reducible to this has reduced to. So now you just need to multiply with a positive 2. So can you see dt by dx? Minus 2, you multiply with minus 2. So minus 2xt is equals to minus 2x cube. Can you see this is clearly a LDE? in t. So t multiply integrating factor. So we have to calculate integrating factor. IF will be equals to e raised to power integral of minus 2x dx. So this will be e raised to power minus x square. Yes. So t e raised to power minus x square is equals to integral of minus 2x cube e raised to power minus x square dx plus c. And now you have to just integrate this. How to do that? So first of all, you have to put, yes, how to do that? How to do this integration? So this is the integration e raised to power minus x cube hai kya? X square. Yes, x square. So you need to just do this integration. How to do that? By putting x square is equals to t. So in here you have to put x square is equals to t. The moment you put x square equals to t, so 1 x square, so x cube we have na, x square will be t and x dx will be dt. And then you have to apply by parts. Okay. I hope that this question will be clear. You will be able to do that, right? Okay. All right. Yes. So now I'll be sharing more questions. So I have more questions, right? So this was the last question of today. And I'm having questions from vector. Can you see vector? So these are the homework questions. Again, one question from definite integration, right? So these are the homework questions that I'll be sharing with the PDF. Again, we have a question from vector. So many questions are there, right? So matrix, okay. Again, matrix or determinants you can say, right? Again, matrix, okay. All right, probability, we have question from probability, and we have statistics, right? So these are the homework questions that I'll be sharing with the PDF, okay? So now what we need to do is we just need to wind up the session, and I'll meet you tomorrow, because tomorrow we are having a mock test which is completely based on class 12th syllabus, okay? So I'll see you tomorrow. This is me, Namrata, signing off. Okay, and yes, so I cannot just switch off the live streaming. So meanwhile, I'll be actually saving this PDF. I have to tell my team that they will have to switch off. Okay, so this is my yes. Okay, and yeah. So the session will be live for a few minutes, because I have to tell them.